Hello everyone. In this lesson, we will explore reference variables and how they work in C++. Reference variables are aliases for an existing variable, and in embedded system, references can be used to avoid copying large amounts of data, which is crucial for performance and memory efficiency. Let's start by copying our existing project and paste it. I will rename it to reference variables. Close this project. I will delete temporary files from here and let's open main.cpp where I have shown the class and object. I will remove all this and remove this. We declare a normal variable like this, and we declare the reference variable with ampersand ref, and reference will always have they will always be initialized, and they will point to a valid variable, like I have here pointed it to the value. Okay, and let there be another variable called as val1, and that will point to value. So what I am doing here is I am assigning value with val with 50 and creating an reference. So reference is the alias for val, and it will always point to the value val. And I have created another value 1, and it would copy while assigning it to the val, the data of val will be copied to val1. So here what I will do is I will print the statement. First of all, let's print val ampersand d forward slash sam forward slash r then comma val, and like I will copy this, and let's see the value of the reference, and here we will see value of the val1. Okay, let me run it and open my Teradata. Here I have connected my board and the COM board. So let's wait and run it. Okay. Open Teradata. And now if I press the reset button, here you will see that all the values have 50. But now let me make a minor change over here, and ref will point to 100. Okay. Now let us print the same values again. So one more, I will add a print statement. Just I will add some lines for spacing. Okay. Now let us build it and run the application. I will clear the screen and yeah, yeah. See, after the reference is uh, uh, changed to value 100 over here in the line 28, the value is the val is changed to 100, but still the value 1 is having the copied value, that is 50. Okay, so this is the reference. And now if we compare it with the pointer, it has lot of advantage over pointer. Like for example, in pointer, we take we assign the pointer, and then we have to dereference to modify the value in the pointer. So if I take, for example, um, there is a pointer in ptr equal to ampersand val, and then what we need to do here is uh, if we want to print the value of the pointer, let me copy this line as well as this line, and here over here ptr is there, and I will have to dereference the value to read it in the console. So while we put the asterisk, it is our dereferencing. And let's run it again. Clear the screen and let me clear the buffer. Okay. See, the pointer is having the value 100. Okay. Because the value here, the reference changed the value to 100. Okay. So the advantage here is that we don't need in the reference we can directly use without dereferencing. We don't need it is already a reference or the alias of the original value, and here we have to dereference the pointer value. Then the second advantage what I see here is like it the references can never be a null can never point to a null pointer. Okay, like if you want the reference to be, I mean, it should have a valid value. Okay, like you cannot simply make another reference like this. It would the compiler would give you the error. See, a reference one declared as reference but not initialized. So you cannot initialize as an empty. But in case of pointer, we can initialize at as empty pointer. So it would give the garbage value in case of pointer. Okay, like here. Okay, it's a redeclaration. I will make it pointer one. So in case of here, you see it is unused variable, it is showing, but we are not seeing any error like it's not pointing to a valid memory location. So either it could be like this or we assign it to be a null pointer. Okay, so it will show some garbage value over there. Then all we can also reassign the references. We can also reassign the pointers, but we cannot reassign a reference to point to a different memory location. The reference, like here, it will always point to the value here, but it will not point to even if we can assign the value of val1 to the reference. Like if I declare over here uh, reference equal to val1, it will assign the value of val1 into the reference. Okay, but it will never point to the memory location of the value 1. So like if I copy it for now, and let's see what happens, and let's run it. Let me clear the buffer and let me press the reset button. See, again it pointed to the 50 because the last value that val1 was having is 50. So it will point to the uh, uh, same memory location, and the value of the first variable, that is val, will change back to 50. Okay. So that was a brief lesson about the use of references in the C++. Thank you very much.